To study, not study, revise these receptors. So we were done with these receptors. Let's study about intracellular. Why we need intracellular receptors? Because we want something that is inside the cell and that can talk to these type of hormones. The hormones that can jump the boundary, the the border of the cell. So we have something called a cytoplasmic and nuclear receptors. Cool, we have something very cool here. Okay. So cytoplasmic receptor. So the deal with cytoplasmic receptor is that it doesn't matter if you have inside the nucleus or outside. Eventually this receptor has to go inside this nuclear membrane. So that's the concept, basic. So it stays binded with heat shock protein. Heat shock protein is like a lock on the receptor. Until unless you get rid of heat shock protein, the receptor won't be activated. So heat shock protein, we need to get rid of heat shock protein. So it stays inactive and the hormone binds with the receptor and then heat shock protein is removed. Cool, the receptor now is activated. And after the receptor is now activated, the hormone receptor, these two together, complex is formed, and then this complex move inside the nucleus, and then the final action happens. Whatever the final action is, transduction, translation, whatever it is. Cool. What kind of hormones can stuck to this cytoplasmic intracellular receptor? Aldosterone, cortisol, testosterone, vitamin D. Cool. Estrogen, testosterone, aldosterone, cortisol, vitamin D. Cool. These are all lipid soluble hormones. Okay, these can cross lipids. Okay, let's try to study about a nuclear receptor. Nuclear receptor means there's nuclear membrane and this receptor is inside, just close to nucleus. Okay, we understand this. Cool. What kind of things can go to this nuclear receptor? First, thyroid hormone. I know you think T3 and T4 they cannot cross, but actually T3 T4 cannot cross. It's true, but thyroid hormone can actually cross, and thyroid hormone goes inside the nuclear membrane, jumps. Vitamin A jumps. Srazu, it's not Srazu, directly. Cool. Estrogen, this one. Cool. Progesterone, we need progesterone for your uterus. Cool. So these all four type of hormone, they jump directly inside the nuclear membrane, and then what happens is that they try to understand this structure. It's not so okay wait it's not so difficult structure. Cool. We have this structure of nuclear receptor. It has a AB part, it's C, D, E, and F. The most important part is E because it's a ligand binding domain. It's where the steroid hormone binds. It causes the change. Cool. AB called N terminal. It has activation function 1. It's a site called activation function site. We call it AF1. No hormone is needed here. It's an on-off switch for transcription. Okay. What about C? It's a DNA binding domain. DNA binds here. It's the location. For what? For DNA to bind. It has a DNA binding site and it has one stabilizer finger. It has two zinc fingers. Cool. Let's talk about D. It's called hinge region. It's a linker between C and E. Cool. This is how the DNA binds, how tightly the DNA binds, to E. This is where the DNA binds. This is where the hormone binds. So this is how this D is responsible, how tight the DNA binds to the hormone. Cool? Cool. Ligand binding, we already know that. And the tail also has activation factor, and we call this activation factor number 2, AF2. So AF1, AF2. Cool, now you understand this. What about neurotransmitter? Well, there are two types of neurotransmitter inside your brain. First is ligand gated. It needs a ligand. Other is metabotrophic, aka GPRC. They are just but G coupled protein receptor, serpentine receptor. They are present in brain too. Cool. Metabotrophic, GPRC. They are slow in speed. They need second messenger. What kind of neurochemical can stick to these kind of receptor? GABA B, muscarinic acetylcholine. Cool word, acetylcholine. Okay, what about ligand gated receptor? These are ion channels, so they are fast. Lot of negative and positive charge going down and up, changing electronegativity of the cell. Cool. So ion channel open, lot of negative come in or maybe out, whatever, depending upon the situation. And what attaches? Nicotine attaches here. Muscarinic attaches here. M for muscarinic, M for metabotrophic. Cool. Nicotine acetyl. Okay, here as well. Nicotine acetyl. Nicotine acetyl. Choline. GABA A, GABA C. They are fast because AC is fast. AC is fast. You must need fast AC. If you have a slow AC, you will die of hot weather.